We're a very large country, but we crowd most of our people into fairly small areas. It all started when I was on a trip to Boston for a weekend, and I was stuck for 4 hours just going a couple miles, and I thought there must be a better way. We proposed a magnetically levitated train back in 1966. One of the people working on it thought of the term maglev, which is short for magnetic levitation. Maglev is like a train in that it moves along the ground, but it's suspended, doesn't contact the track in any fashion.
I have two ordinary refrigerator door permanent magnets with a hole in them. If I orient them one way, they're attracted to each other. If I turn one over so their magnetic fields oppose, then it is indeed levitated like this.
What you're seeing here is the magnet being levitated from the superconductor. I can set it right on top, and it won't leave its magnetic field. It'll stay on top of that superconductor even when I spin it. You're floating on air.
But if these magnets are really superconducting magnets, which are much stronger and much lighter, they can cause the vehicle to levitate about 6 inches above the track. Then it's frictionless. It can just glide along, so it just goes at any speed that you want.
Okay, now the superconductor at this temperature should levitate itself on this track because it works as a magnet. Okay, here we go.
When you build a maglev system, you really require 3 things: that it levitate. The second thing you have to do is to keep it stable, have it not slide off to the side. And you do that by shaping these loops and arranging them so that if it moves to either side or up and down, it's stable. And the third thing you have to do with a maglev is push the vehicle. And that's done by putting another set of windings in the track which meander back and forth like this, like the oxbows on a river, and they carry an alternating current from a power line. When they interact with these strong magnets on the vehicle, they just push it along at a constant speed.
One easy way to visualize it is like a surfboard.
A series of magnetic waves going down the track, and you're on your wave, the vehicle ahead is on his wave, both travel at the same speed. Instead of traveling at 50 to 60 miles an hour, if you're lucky, now you'll be able to travel 250 to 300 miles an hour on a maglev line.
Now that's just the beginning. Put the vehicles in a tunnel that can be made very airtight. Now you can go at 3,000 miles an hour from London to New York in 2 hours.
We think it's an ideal way to do transportation in the future. Comparing maglev going at 300 miles an hour with a car, you're traveling 5 times as fast and using 1/2 as much energy. Compared to a plane, which is traveling at 500 miles an hour, you're using 1/4 of the amount of energy in a maglev device. It's non-polluting, can carry an enormous volume of traffic. With maglev being able to travel at 300 miles an hour, you can easily live 150, 200 miles away from your place where you work.
Technology and science are central to our existence and our well-being and standard of living today. It's wonderful for young people because the opportunities to make significant contributions is there. I mean, you can very quickly make a mark, and that's just more fun.